Hello and welcome to today's lesson on changes of state. In today's lesson, we will explore the basics of changing states of matter, such as from solid to liquid, liquid to gas, and vice versa. We will then discuss different types of state changes, including melting, freezing, boiling, evaporation, condensation, and sublimation. Following this, we will understand that changes of state are physical changes, not chemical ones. We will differentiate between physical and chemical changes with examples to clarify these concepts. Finally, we will learn about the conservation of mass during state changes, a fundamental principle of physics. So far, we have explored the properties of solids, liquids, and gases. This foundation is crucial because understanding these properties helps us make sense of how substances transition between these states. So, without further ado, let's get started. First, let's recall that matter exists in three primary states: solid, liquid, and gas. Each state has distinct properties based on the arrangement and motion of its particles. Understanding these properties is crucial as we explore how matter transitions between these states. First, we have melting. When a solid is heated, its particles gain energy and vibrate more vigorously until they break free from their fixed positions. This transition from a solid to a liquid is called melting. For instance, ice melting into water when heated. The reverse of melting is freezing. When a liquid loses energy, its particles move more slowly and get closer until they arrange into fixed positions, forming a solid. We see this when water turning into ice in the freezer. When a liquid is heated, its particles gain enough energy to overcome the forces holding them together, turning into gas. Boiling refers to this happening throughout the liquid, while evaporation usually happens at the surface. An everyday example is water boiling into steam when heated on the stove. The opposite of boiling is condensation. Gas loses energy, and its particles come closer together to form a liquid. You might see this when steam hits a cold surface, like a bathroom mirror after a hot shower, forming water droplets. Some substances can change directly from a solid to a gas without passing through the liquid state. This is called sublimation. Dry ice, solid carbon dioxide, is a classic example, turning directly into carbon dioxide gas. A change of state is a physical change, not a chemical one. This means that the substance itself doesn't change, only its state does. With physical changes, the molecular structure remains the same even if the state changes. For example, when ice melts into water, it's still H2O. In physical changes, the bonds between molecules may shift, but the molecules themselves don't change. A key point is that many physical changes are reversible, like melting ice that can be refrozen. In contrast, chemical changes result in new substances with different properties. For instance, burning wood is a chemical change, creating ash and smoke, substances that can't go back to being wood. These changes involve breaking and forming chemical bonds, which is irreversible. When a substance changes state, its mass stays the same, a principle known as the conservation of mass. This concept asserts that the total mass remains constant through any physical or chemical transformation. During a state change, the particles are rearranged, but their total number and mass don't change. It's akin to reshuffling building blocks. The shape can change, but the total number of blocks remains the same. For instance, if you measure the mass of ice and the liquid water it turns into, you'll find they have the same mass. This demonstrates conservation of mass during physical changes. Today, we delved into the fascinating world of changes of state. We explored how matter transitions between solid, liquid, and gas through processes like melting, freezing, boiling, evaporation, condensation, and sublimation. Each process involves changes in particle arrangement and energy. We clarified that changes of state are physical, not chemical. The substance itself remains the same, only its state changes. Physical changes are often reversible, while chemical changes result in new substances with different properties. We then learned that mass remains constant during state changes. The total amount of matter doesn't change, just its form. This principle is crucial for understanding how matter behaves in different states. Next time, we'll build on this understanding by introducing internal energy and energy transfers. See you in the next lesson.